So, good day everyone. Welcome to my channel Development Rishi. I am Dev. In this chapter number 4 of the Linux terminal course, we are going to talk about directory and file manipulation. So these are some of the commands that we are going to talk about in this chapter. The first command that we are going to look at is the cp command, which is used to copy files and directories. Move mv command used to move and rename files and directories. Mkdir is used to create directories. Rm command is used to remove files and directories. And finally, ln command is used to create hard and symbolic links. Okay, so among the commonly employed Linux commands, these 5 hold significant importance. They serve the purpose of manipulating both files and directories. To be honest, certain tasks accomplished by these commands can be more conveniently executed using a graphical file manager. With the file manager, we have the ability to effortlessly drag and drop files between directories, perform cut and paste operations, delete files, and more. Hence, one might question the rationale behind utilizing these traditional command line programs. The key lies in the advantages of power and flexibility. Although performing basic file manipulation is effortless using a graphical file manager, complex tasks become more manageable with command line programs. Consider the scenario where we need to copy all HTML files from one directory to another, but only those that are not already present in the destination directory or are newer than the existing version. Achieving this becomes quite challenging using a file manager, but remarkably straightforward through the command line. So for such a requirement, this is the command that we might use. So we are saying is cp, then we are passing argument saying -u star.html and then the destination folder. Okay, now what this all means will become clearer later in this chapter. Alright, wildcards. What are wildcards? Prior to diving into the utilization of our commands, it is crucial to discuss a shell feature that amplifies the power of these commands. Given the frequent usage of file names within the shell, it offers special characters known as wildcards designed to expedite the specification of groups of file names. By employing wildcards, also referred to as globbing, you can conveniently select file names based on patterns of characters. The table provided below outlines the various wildcards and their corresponding selections. So these are some of the wildcards used in the terminal. Star matches all characters. Question mark matches any single character. Characters inside square brackets matches any character that is a member of the set characters. Not characters inside square brackets matches any character that is not a member of the set characters. Then the class matches any character that is a member of a specified class. Following are the most commonly used character classes. All num matches any alphanumeric character. Alpha matches any alphabetic character. Digit matches any numeral. Lower matches any lowercase letter. Upper matches any uppercase letter. Alright, so the utilization of wildcards enable the creation of intricate selection criteria for file names. Presented below are a few examples of patterns and corresponding matches they produce. Star produces all matches, all files. G star, any file beginning with G. B star.text, any file beginning with B followed by any characters and ending with the .txt extension. Okay. Data and 3 question marks, any file beginning with the data followed by exactly 3 characters. ABC star, any file beginning with either an A, B or a C. Okay. Backup dot 0 to 9, then 0 to 9 and another 0 to 9. Any file beginning with backup dot followed by exactly 3 numerals. Upper star, any file beginning with an uppercase letter. Not digit star, any file not beginning with a numeral. Star lower 1, 2, 3. Any file ending with lowercase letters or the numbers 1, 2 or 3. Wildcards can be applied with any command that accepts file name as arguments, but we will delve deeper into this topic in chapter number 7. Okay, so now what are character ranges? if you're interested, you can read through this little paragraph. Okay, let's talk about mkdir command, which creates directories. To create directories, the mkdir command is employed. Its functionality operates in the following manner. Mkdir directory. Regarding notion, when an argument in the command description is followed by 3 periods as mentioned above, it indicates that the argument can be repeated in the following manner. So you can either say make dir1, or you can say make dir1, dir2, dir3. So what this command will do, it will create a folder called dir1, but if you pass this command, it will create 3 folders called dir1, dir2, and dir3. Alright, so next, the cp command, which is used to copy files and directories. So this is how you would utilize the cp command. You will say cp item1, item2. So to copy a single file or directory named item1 to another file or directory named item2, you can utilize the following approach. cp item directory, to copy multiple items, either files or directories, into a directory. Useful options and examples. Listed below are several commonly employed options, both the short options and the equivalent long option for the cp command. Guys, don't worry, we will do the practical side of this later in this chapter. Okay, so what is -a option or --archive? Copy the file and directories and all their attributes, including ownership and permissions. Normally, copies take on the default attributes of the user performing the copy. Okay, -i or --interactive. Before overwriting an existing file, prompts the user for confirmation. If this option is not specified, cp will silently overwrite files. -r or recursively copy directories and their contents. This option or the -a option is required when copying directories. -u or --update. When copying files from one directory to another, only copy files that either don't exist or are newer than the existing corresponding files in the destination directory. -v or --verbose displays informative message as the copying is performed. So some of the examples that we can consider. So let's say cp file1, file2, copy file1 to file2. If file2 exists, it is overwritten with the content of file1. If file2 does not exist, it is created. cp-i file1, file2, same as above, except that file2 exists, the user is prompted before it is overwritten. cp file1, file2, dir1. Copy file1 and file2 into directory dir1. dir1 must already exist. cp dir1 / dir2. Using a wildcard, all the files in directory 1 are copied into directory 2. dir2 must already exist. cp-r dir1, dir2. Copy the contents of the directory dir1 to directory dir2. If directory dir2 does not exist, it is created, and after the copy will contain the same contents as directory dir1. If directory dir2 does exist, then directory dir1 and its contents will be copied into dir2. Okay, mv, move and rename files. The mv command serves dual purpose for moving files and renaming files. Depending on its usage, in either scenario, the original file name ceases to exist after the operation. The mv command is employed in a similar manner to cp. So this is how you would apply it. mv item1, item2 to move or rename the file or directory item1 to item2, or mv item many items to directory 2 to move one or more item from one directory to another. Useful options and examples. So mv shares many of the same options as cp. So -i will ask you to confirm before overwriting a file which already exists. -u, when moving files from one directory to another, only moves files that either don't exist or are newer than the existing corresponding files in the destination directory. /-v displays informative messages as the move is performed. Alright, so these are some of the examples. Please have a look through this. Okay, then we'll move to the rm command. So the rm command is used to remove or delete files and directories. Rm item, where item is one or more files or directories. Useful options and examples. Here are some of the common options for rm command. -I, as before, it will prompt the user for confirmation. -R, recursively delete directories. This means that if a directory being deleted has subdirectories, delete them too. To delete a directory, this option must be specified. -F or /force ignores non-existent files and do not prompt user. This overrides the interactive option. -V or /verbose displays informative messages as the deletion is performed. Okay, so these are some of the examples. rm file1, delete file1 silently. rm-I file1, same as above, except the user is prompted for confirmation before the deletion is performed. rm-R file1, the one, deletes file1 and the1 and its contents. rm-rf file1, the1, same as above, except that if the either file1 or the1 do not exist, rm will continue silently. Okay, be careful with rm. Alright, so please quickly have a read through this. This is a little warning for you before using the rm command. Okay, ln, create links. The ln command is utilized to create either hard or symbolic links and can be employed in one or two manners. ln file link to create a hard link, and ln-s item link to create a symbolic link where item is either a file or a directory. Alright, so hard links are only for files and soft links can be used for files and directories. Okay, we'll get into the details now. What are hard links? Hard links are the traditional method in Unix for creating links, while symbolic links are a more recent addition. By default, every file possesses a single hard link that corresponds to its name. When a hard link is created, an additional directory entry for the file is generated. However, hard links come with two significant limitations. A hard link is restricted to referencing files within its own file system. In other words, it is incapable of referencing to a file that exists on a different disk partition than the link itself. A link may not refer to a directory. Okay, a hard link bears no distinguishing characteristics from the file itself. Unlike a symbolic link, when you view a directory containing a hard link, there will be no specific indication of the link's presence. When a hard link is deleted, the link itself is removed, but the file's content persists. That is, the allocated space is not deallocated until all links to the files are eliminated. It is crucial to have an awareness of hard links, as you may come across them occasionally. However, contemporary practices tend to favor symbolic links, which we will discuss in the following section. So now, what are symbolic links? Symbolic links were developed to surpass the limitations of hard links. Symbolic links function by generating a distinct file type that includes a textual pointer to the referenced file or directory. In this aspect, they operate similarly to a Windows shortcut, although it is important to note that the symbolic links predate the Windows feature by many years. A file that is referenced by a symbolic link and the symbolic link itself appears almost identical. For instance, if you write something to the symbolic link, the changes are applied to the reference file. However, when you delete a symbolic link, only the link itself is removed when the file it points to remains unaffected. However, when you delete a symbolic link, only the link itself is removed while the file it points to remains unaffected. If the file is deleted prior to the symbolic link, the link will persist but no longer have a valid target. In such cases, the link is considered broken. Some implementations of the ls command displays broken links in a distinct color, such as red, to highlight their existence. The concept of links may initially appear perplexing, but do not worry. We will delve into practical examples and explore these concepts together with the aim of providing clarity along the way. So hang in there and hopefully everything will become clearer as we proceed. Okay, so now it's time to play. Let's do some practical work. Okay, as we are about to engage in practical file manipulation, let's establish a secure location for experimenting with our file manipulation commands. To begin, we require a directory to serve as our working space. We will create this directory named playground within our home directory. So let's create this directory. Creating directories. The mkdir command is utilized for directory creation. To establish our playground directory, we will confirm that we are currently in our home directory and proceed to create the new directory as follows. Okay, so first let's open the terminal. Let's get to our home directory and then we'll create a directory called playground. So we'll utilize the mkdir command and we'll type the name of the directory that we want to create. Okay, so we'll say mkdir playground. So now if you do ls-l, you'll see the playground directory has been created. Okay, to add some intrigue to our playground, let's create a couple of directories within it named dir1 and dir2. To achieve this, we will change our current working directory to playground and execute another mkdir command. Okay, so let's create two directories, dir1 and dir2, inside the playground directory. To do that, let's first move inside the playground directory. So we'll say cd playground, and to confirm that we are inside this playground directory, we'll say ls. There is nothing inside the playground directory. So let's create two directories here. We'll call them dir1 and dir2. Okay, now we'll do the ls command and it confirms that we have two directories inside the playground directory called dir1 and dir2. Okay, it's one more thing that the mkdir command allows us to provide multiple arguments, enabling the creation of multiple directories with a single command. Okay, so now copying files. Now let's introduce some data into our playground. We can accomplish this by copying a file with the cp command. We will duplicate the past wd file from /etc directory to our current working directory. Okay, so we'll say cp /etc/pastwd and the current directory. Okay, so to confirm if the pastwd file was copied to the current folder, we can just type the ls command and here you go, the pastwd file is now here. Okay, observe how we utilize the shorthand notation for the current working directory denoted by the single trailing period. Consequently, if we execute the ls command, we will witness the presence of our file. Okay, so we did the ls command, but we can type -l at the end of the ls command to get the detailed information of the current directory. Okay, now for a touch of amusement, let's repeat the copy operation while employing the -v option to observe its effect. Okay, so let's apply the same command, but we'll pass the -v argument. Okay, the cp command executes the copy operation once more while displaying a message that indicates the performed action. It's important to note that cp overwrites the initial copy without providing a warning. Once again, this exemplifies cp's assumption that you are aware of what you are doing. However, if you desire a warning, we can include the I option. Okay, so if you are concerned that you may make a mistake or overwrite a file that you don't want to, you can just pass the I argument, and now it is going to ask you if you want to overwrite the PASSWD file, and when you pass Y, which stands for yes, will complete the operation. Okay, when prompted, responding with a Y will result in the file being overwritten, while any other character such as N will cause CP to preserve the file without making any changes. Okay, so moving and renaming files. Now consider that the name pastwd may not align with the playful nature of our playground. Let's modify it to something more fitting. Okay, so let's rename this file, the pastwd file, to something else. Let's call it fun. So we'll say pastwd fun. So the command we're using is mb pastwd fun. Okay, so now if we do the ls command, you can see the pastwd file has disappeared and a new file called fun is created. Okay, let's add some fun by circulating our renamed file through each of the directory and then returning it back again. Let's move this file to directory 1. Let's say do that, we'll have to say mv fun dir1. Okay, so if we apply the ls command now, that file has disappeared named fun. So if we do move to the dir1 and type ls, you can see the file fun is inside the dir1. Okay, let's move back. Now let's move the file inside dir1 called fun to dir2. To do that, we have to apply this command, the mv dir1/fun dir2. Okay, so now if we move to dir2 and type ls, you can see the fun file is now inside dir2. Okay, now let's move the file fun back to the current directory. To do that, we'll say mkdir2/fun and then current working directory. Okay, now the file has moved back to its original location. To confirm, we can type the ls command, and here you go. The fun file is back to its original position. Alright, let's explore the impact of mv command on directories. Initially, we relocate our data file into dir1 once again. So let's move the fun file back to dir1. Okay, then move dir1 into dir2 and confirm it with ls. Okay, so to do that, we'll say mv dir1 to dir2. Okay, now if we type the ls command, you'll see there is no dir1 over here. But if you type the ls command and say dir2 at the end of it, it will list all the files and folders inside dir2. And as you can see, the dir1 folder is now located inside dir2 folder. Okay, and now if you want to view the files and folders inside dir1, all you have to do is ls-l dir2 dir1. Okay, and then type enter, and you can see the file fun is located inside dir1, which is further located inside dir2. Okay, which is located in our current working directory. Right, please note that since dir2 was already present, the mv command moved dir1 into dir2. If dir2 had not existed, mv would have instead renamed dir1 to dir2. Finally, let's restore everything to its original state. Okay, to do that, we'll say mv dir2 dir1 and then the current working directory. Confirm that dir1 is outside dir2. We'll say ls, it is. Now let's move the file fun outside the dir1. Okay, we'll say mv dir1 fun and then the current working directory. To confirm we have moved the file fun outside dir1, let's confirm it with the ls command. We have, there you go. Okay, now let's talk about creating hard links. Let's delve into creating some links, starting with hard links. We will generate a few links to our data file using the following method. So first, let's create a hard link for the file fun. To do that, we'll utilize the ln command. So we'll say ln fun and the name of the link, we'll call it fun hard. Okay, so now to confirm that the link has been created, we'll type the ls command, and here you go. You can see fun-hard is created. Let's create a couple more links inside dir1 and dir2. So to do that, we'll say ln fun dir1/fun-hard. Okay, and then again we'll create another link inside the dir2. Okay, let's confirm the existence of the new links. We'll say ls dir1, and as you can see, there is a link inside dir1 called fun-hard. Let's confirm it for dir2 as well, and here you go. Another link is created inside dir2 as well. Okay, upon closer inspections, you may observe that both fun and fun-hard in the listing shares a 4 in the second field over here. Okay, this number represents the count of hard links currently associated with the file. It is crucial to remember that a file always possesses at least one link, since its name is established through a link. However, we can ascertain that fun and fun-hard are indeed referring to the same file. In this scenario, relying solely on the ls command does not provide a definite answer, although we can observe that fun and fun-hard shares the same file size, in this case the field number 5, which is this. This information alone does not guarantee their identity. To resolve this uncertainty, we'll delve into deeper in this matter. Okay, when contemplating hard links, it proves beneficial to envision files as comprising two components: the data part containing the actual file content and the name part holding the file's name. By creating hard links, we essentially generate additional name parts that all point to the same data part. The system allocates a series of disk blocks to form what is known as an inode, which is subsequently linked to the name part. Each hard link thus refers to a specific inode encapsulating the file's content. To unveil this information, the ls command provides a solution. By utilizing the -i option, we can invoke the desired functionality. Alright, so let's check it out. We'll say ls dash L and then I. Okay, now as you can see here, the fun hard link and the file fun, they both have this unique ID, right? So if these two are equal, that means they're both pointing to the same file. All right. So to confirm this, you can also say ls-l I, and then we'll list all the files inside the one. As you can see, the link inside the one also possesses the same ID as the one outside and as the same original file. Okay, so this is how we can confirm that these two links point to the same file. Okay, in this listing version, the first field corresponds to the node number. Upon inspecting, we observe that both fun and fun hard possesses identical inode op numbers, thereby confirming identity as the same file. Okay, now let's talk about creating symbolic links. Symbolic links were developed as a solution to overcome the limitations of hard links. Hard links are unable to extend across physical devices and are limited to referencing files rather than directories. Symbolic links, on the other hand, serves as a distinct file type that includes a textual pointer to the target file or directory. Creating symbolic links is similar to creating hard links. So to create a symbolic link, all you have to do is type ln-s, which is specifying a symbolic link, then the name of the file, then name of the link. Okay, to confirm that the link was created, yes, as you can see, fun-sim was created and it's a symbolic link pointing to this file. Okay, now let's create two more links. So it's ln-s fun-sim. Okay, and we'll create another one inside the two. Okay, the initial example is quite simple. We merely include the -s option to generate a symbolic link instead of a hard link. However, how do we approach the following two examples? Recall that when we establish a symbolic link, we essentially create a textual representation indicating the relative location of the target file in relation to the symbolic link. This becomes clearer when we examine the output of ls command. Okay, so let's check the one. And over here, we can see that symlink is pointing to a file that is in its parent directory, which is here, okay, inside the playground directory. Okay, because symbolic links use a textual representation to point to its original file. It basically stores a path to that file. So in relation to this symbolic link, which is inside directory 1, the original file is in its parent directory. So first we are moving to the parent directory and then we are naming the file. Okay, in the directory listing for fun-sim in dir 1, we can observe that it is a symbolic link indicated by the leading L. So over here, this confirms that this is a link. Okay, over here as well. In the first field, furthermore, it points to /fun, which is accurate in relation to the location of fun-sim. The file fun is situated in the directory above it. It's worth noting that the length of the symbolic link is 6, corresponding to the number of characters in the string /fun rather than the length of the file it is referencing. Okay, so this basically shows the number of characters inside the fun-sim link, okay, which are 6. Okay, 1, 2, 3, 4, 5, and 6. All right. When creating symbolic links, you can either use absolute path name such as ln-s/home/username/playground/fun and the destination the one/fun-sim, or relative path names as demonstrated in our previous example. Utilizing relative path names is preferable since it enables the renaming or moving of a directory containing symbolic links without causing them to break. In addition to regular files, symbolic links can also reference directories. So let's create a symbolic link to a directory. So we'll say ln-s one and the name of the symbolic link. Okay, so if we do ls-l, you can see the one-sim has been created, which is pointing to the one. Okay, now let's talk about removing files and directories. As mentioned previously, the rm command is employed for deleting files and directories. We will now utilize it to tidy up our playground. To begin, let's remove one of our hard links. Okay, so let's remove the first hard link that we created. To do that, all we have to do is say rm fun dash hard. And now if we type the ls-l command, you will notice that the fun hard link was deleted, which was available previously. Okay, the deletion process went as anticipated. The fun dash hard has been successfully removed and the link count for fun has decreased. As you notice here, it is now 3, okay, instead of 4 over here, okay, because we have deleted one link. Right, now let's proceed with deleting the file fun. For some additional enjoyment, we'll include the -i option to observe its behavior. Okay, so now let's say rm-i fun. So now it is going to ask us to remove the regular file fun. We'll say y, which stands for yes, and then the enter key. Okay, upon confirming with a y at the prompt, the file has successfully deleted. However, let's examine the output of the ls command now. Did you notice what happened to fun-sim, as it is a symbolic link pointing to a file that no longer exists? The link has become broken. So now if we type ls-l, as you can see, the link fun-sim is pointing to a file which does not exist, which means it is showing in red. It was showing in this teal blue color before. Okay, in most Linux distributions, the ls command is configured to highlight broken links. For example, on Fedora system, broken links are displayed in blinking red text. While the presence of a broken link is not inherently dangerous, it can make things look messy. If we attempt to use a broken link, we will encounter the following situation. So now if we type the ls command and try to open the fun-sim link, it will say no such file or directory. Okay, let's clean up a little bit. We'll delete the symbolic links. Let's remove fun-sim and the one-sim. Okay, so apparently we forgot to add one when we originally created the link. So to remove it, all we have to do is remove the one from the name, and then when we press enter, of course the fun sim was deleted in the previous operation, and now the dash sim must have also been deleted, and it has. Okay, it is important to keep in mind that when working with symbolic links, most of the file operations are performed on the target of the link rather than the link itself. However, there is an exception with the rm command. When you delete a symbolic link, it is the link itself that gets deleted, not the target file or directory. To conclude, we will delete our playground folder. To accomplish this, we will navigate back to our home directory and employ the rm command with the recursive option -r to delete the playground directory along with all its contents, including any subdirectories. To remove our playground directory, we'll move back to our home directory. To confirm, we'll just type ls, and as you can see, we are back in our home directory, and now we want to remove the playground directory because there are subfolders inside the playground directory. We'll pass the -r argument, which will recursively delete everything inside the playground directory before it deletes the playground directory itself. Okay, so now when we press enter and type the ls command, the playground directory is gone. Okay, right, so now let's summarize the chapter. We have covered a significant amount of material, and it may require some time for everything to fully sink in. I encourage you to repeat the playground exercise multiple times until you feel comfortable with it. Developing a solid understanding of fundamental file manipulation commands and wildcards is crucial. Don't hesitate to enhance the playground exercise by adding additional files and directories and experimenting with wildcards to perform various operations. While the concept of links might seem perplexing initially, invest the time to grasp how they function because they can prove invaluable in certain situations. Alright guys, so I'll end the chapter over here. In the next chapter, we'll talk about working with commands, and in the meantime, I will highly recommend you to try this playground exercise a couple more times until you have fully grasped the concept of all different commands. Alright, so in the meantime, have a good one, and I'll see you in the next video.